this again. So here we go. So students, how many squares are there in figure number 75? So I'm going to ask and see who has an answer. So Miss Kennedy, what do you think the answer is? 74. 74. Okay. Anybody else got an answer? It could be right, could be wrong. Not sure. Elisa. Elisa. 76. Anybody else? You had your hand raised. What do you think? You think it's 74? Shanubi, what's your name over here? I forgot already. Dr. Pepper? James, you had your hand up, didn't you? What do you think it is?
I got 76.
76. Should we take the average and make it 75? No. Josue? I don't know. Okay. I want to say Talon. I know that's not right. It starts with a T. Talon. It's like Talon, only Talon. Do you have an answer? It's okay if you don't, because this is brand new. Destiny? She thought it was 76. Can anybody explain how they got their answer? Zari, let's hear from you. Now, she didn't give me an answer. Let's see what she has to say. Feel like it should be 76 because they added 1. So figure 1, how many squares do you see? 2. Figure 2, how many squares do you see? 3. Figure 3, how many squares do you see? 4. So the answer is always 1 more than the number that's there. Okay? So you have the right idea. You just went backwards a little bit. So if it is figure 75, then if I add 1, the answer should be 76. Very nice. Question.
So is figure number 75 this whole problem?
It is a random number that we are saying as we look at this pattern. That is a great question. As we look at this pattern as it is given to you, do you recognize that the figure number with the number of squares is always the number of the figure plus 1 to get the total number of squares? Because we don't want to have to write out figure 4, figure 5, figure 6, etc. So we are using a pattern to see and project what the correct answer will be. Now, are you ready for your minds to be blown? Here's the question. What if I had figure number n? Ooh, now n could be any number that I give you. Figure n, how many squares would be in figure n? Don't answer yet. According to this pattern, what would be the number of squares for figure number n? Raise your hand if you think you have an answer. Okay, I have one maybe hand. It was like this. Figure n using the same pattern. You're right. We don't know what n is. Does it matter? Does it? It's always going to be 1 more, right? So what is 1 more than n? No. Just 1? So the answer would be 1? Figure n. So here we went. Figure 1 was 1 plus this 1, right? Figure 2 was 2 plus this one. No? Good try. Everybody's trying. I love that. Figure 3 is 3 plus this one. So figure n would be, what's the number? What's the value? N, because that is the figure number, n plus 1. It's one more than whatever n is, right? Did that blow your mind a little bit? Does it make sense now, though? Kind of, sort of. Yeah, it's always, whatever n is going to be, it's always going to be just one more. Yes?
So if for all of these figures they were adding 2 boxes, would it be n plus 2?
Yes. Excellent. So then your picture would be a little different. It would look like this, and the pattern is no longer, figure number plus 1. It would be figure number plus 2. So this is all about recognizing a pattern and generalizing it to any value of n. Okay? All right. Shake it out. Shake it out. It's like aerobics class, right? No. All right, let us go, please, to page 5, the mental math. Mental math. All right, how many of these did we do together in class yesterday? 2? The first 2? Just the first 2? Okay. And some people came in a little later, so we're going to do this a little bit together. Okay? Well, I know. No, I know. So you saw some of it. Is that what you're saying? All right. So we are starting with this statement. 13 times 17 is equal to 221. We are basing all of our mental math on that equation. Okay? Why is that an equation again? What makes an equation an equation? It has an equal sign. Okay? So now as I look at this first space, we had 13, which is the same as what we had here, times 1.7. Well, what did we do to get from 17 to 1.7? We moved the decimal, which means we divided by 10, right? If this is a similar problem, I should get the same answer, except if this is divided by 10, what's that going to do to my answer back here? I would also have to divide by 10. When you divide by 10, you are going to move that decimal point 1 place to the left. So this becomes 22.1. Okay, that's kind of what we did yesterday, right? Okay. So now, using this as our base, again, 13 times 17 is 221. Now I have 130 times 17 equals, I know it's going to be around 221, but how did I get from 13 to 130? What did we do there? We added a 0, but really in number sense, we multiplied by 10. So what is that going to do to my answer? Multiply by 10. And when you multiply by 10, can you get the door, please? You are going to move that decimal point 1 place to the right because it is becoming bigger. So when I move that decimal place 1 to the right, yes.
Is Tyra Wilson here? Tyra Wilson?
She's
not here today?
Yeah.
Okay.
You're welcome.
I have a prize for her, so
I'll
find her.
Okay.
Thank you.
You look lovely. All right. So moving that 1 place to the right means I need to add in a 0, which gives me 2,210. So we did those 2 yesterday. Okay. Not trying to beat a dead horse here. All right. Somebody give me letter C. I don't have it in front of me. 13 times 1,700 equals, right? All right, so go from our base problem. I know it's got to have a 2, and a 1. What changed here? The 2 zeros, which means we multiplied this by 100, which is going to do what to my answer? Multiply by 100, which means I add 2 zeros, go 2 to the right, 22,100. Anybody have that or thinking that? Okay. All right. Letter D. Ooh, is it Mamadou? Can you tell me what letter D says on the paper? I am so sorry. I have another Mamadou. 1.3 times 1.7. I know my answer is going to have a 221. What did I do to get from 13 to this 1.3? Divided by 10. So here, how about 17 to 1.7? Also divided by 10. So what do you think that's going to do to my answer? Divided by 10? If you divide by 10 and then you divide that second thing by 10, then you are dividing by 100. 100. So if I move it 2 places to the left, I get 2.21. Okay? 2.21. How many are there? EFG?
Yeah.
All right. 11:02. I'm so bad with time. E. E. Alex, can you read E for me? Nice and loudly. 2,210 divided by 13 equals. Oh, so now they started with the answer and they're kind of working backwards. Let me get rid of this so we can see this again. Okay. Yep. Here we go. So 2,210. How did that change from 221? Here's 221. They multiplied by 10 and divided by 13. That's the same. I know my answer is going to have a 1 and a 7. So if I took the answer and multiplied by 10, what's going to happen to this answer? It's also going to be multiplied by 10. So there's your decimal point. Multiply by 10. That becomes 170. Okay, 170. All right, I know you're getting antsy. How about letter F? Who can read letter F for me? What's your name again? Demarion. Can you read F for me from the, oh, you don't have it? I'm sorry. Did you get a book? Okay, but you forgot it? Okay. Help him out, somebody. F. 22,100 divided by 17. I know the answer is going to have a 1 and a 3. How does 22,100 compare with 221? Is it bigger or smaller? How many times? That's 100 times bigger than 221. So what must I do with this answer? Multiply by 100, which moves it 2 places to the right, which gives me 1,300. Last one. Letter G, letter G, letter G, letter G, letter G. Kennedy, can you read G for me?
221 divided by 1.
Okay. So 221, the first number did not change. This is the same, right? So divided by 130, I know my answer is going to have a 1 and a 7 in it. How did 130 change from the original problem of 13? Is that right? 221 divided by 130, right? Oh, did you say 1.3? Oh, Miss Sadie, your hearing is horrible. Thank you, I know. All right, how did 13 change to 1.3? We divided by 10, right? It went one space to the left. Now, think about this. If you have a number and you divide it by the same number, okay, we would get 17. So 221 divided by 13 is 17. But now what we're dividing by is smaller. You're making smaller pieces. You're dividing it into smaller chunks. So what is going to happen to the number of chunks that you have? Is it going to be smaller or bigger? Smaller. Who said that? So if I have 221, I divide it by 13, I get 17. If I take 221, I divide it into 1.3 amount of sections, actually you're going to have more. It's going to be bigger. Because you're not changing this, you're changing the size of what you are dividing. So the last one is a little bit trickier. Not intended to be tricky, but it is different. And the answer is 170. And you're like, oh my gosh. Now, is this a big part of this first chapter? No, it's not. But you have to know and understand and kind of look for some patterns. Okay? All right, so when we come back from lunch, we're going to talk about Felicia's Drive. Enjoy your lunch. Hopefully this is recording and going well. Can I have someone with a nice, loud, booming voice read this first paragraph, please?
As Felicia gets on the freeway to drive to her cousin's house, she notices that she is a little low on gas. There's a gas station at the next exit she normally takes, and she wonders if she will have to get gas before then. She normally sets her cruise control at the speed limit of 70 miles per hour, and the freeway portion of the drive takes about an hour and 15 minutes. Her car gets about 30 miles per gallon on the freeway, and gas costs $3.50 per gallon.
Okay. So, and the answer is, I don't know. We haven't even asked the question. So, how many of you right now are like, oh, anybody kind of like that? Why is that? Why are you in somewhat of a little panic? Maybe not everybody is. What kind of problem is this? It's a word problem. Nobody likes word problems, okay? Nobody. It's like, just give me some numbers, tell me add, subtract, multiply, divide, let me do something like that. But when we get to a word problem, we panic, okay? And that's okay, but then you need to come back and say, I can do this, all right? So once you've read it through once and you've kind of panicked, I think the best thing you can do after that is read it again, okay? This time, I'm going to read it. Thank you so much for doing it. You did a great job. And I want you to either underline or pay a little bit more attention to the numbers, okay? Because the first time you're just reading through, you're like, what is going on in this problem? So now I'm going to read it. We're going to pay attention, slow down, maybe underline some stuff, circle, do something like that, okay? So listen a second time. As Felicia gets on the freeway to drive to her cousin's house, she notices she's a little low on gas. There is a gas station at the exit she normally takes, and she wonders if she will have to get gas before then. She normally sets her cruise control at the speed limit of 70 miles per hour. Okay, that's a number, so I'm going to underline that maybe. And the freeway portion of the drive takes an hour and 15 minutes. So 70 miles per hour, it takes an hour and 15 minutes for that freeway. Her car gets 30 miles per gallon on the freeway. And gas costs $3.50 per gallon. Okay? So I have underlined, circled, did something with all the numbers in there. That doesn't mean we necessarily use all the numbers, but that is what I see and observe. Okay? Letter A says, describe an estimate that Felicia might do in her head while driving to decide how many gallons of gas she needs to make it to the gas station at the other end. Describe an estimate she might do in her head while driving to decide how many gallons of gas she needs to make it to the gas station at the other end. Okay? I know. Muhammad's like, no, that's not for that. What are your ideas? This class is not about me telling you we are going to use this technique for this problem. Okay? This is a word problem. They want to know how many gallons of gasoline. We have to go back through the problem and try to figure out what the important stuff is to know for this problem. Okay? So let's talk about it. What do you know? What is important, or what seems to be important for this first question? Taylor.
How long it takes her to drive the freeway?
Okay, so she's on this freeway for how long? 1 hour and 15 minutes. Okay? 1 hour and 15 minutes. That's good to know. I totally agree. That's not the only thing we need to know. What else is important or that we will need to know? How many miles per gallon? Okay, 30 miles per gallon. She can go 30 miles. When we say per gallon, what kind of an operation is that, sort of? Say it again. A fraction or division. Yeah, 30 miles per 1 gallon. Okay, so that looks like that. Is it Destiny? Dalia, that's right. I'm sorry. Dalia, you had your hand up. Were you going to say the same thing? Okay. 70 miles per hour. So in this 1 hour, how far is she going to get on the freeway? 70 miles, right? She's going 70 miles because she gets 70 miles per hour. Now, 15 minutes is a part of a larger amount of time, right? What's the larger amount of time? If you're comparing minutes to a larger amount of time, you're looking at minutes to an hour, probably. So what part of an hour is 15 minutes?
60 minus 15.
No. What part of the entire hour, how much is 15 minutes of an hour? It's a fourth, right? There are 4 15 minutes in an hour. So this is 1/4 of an hour. So if it takes 70 miles, she can go 70 miles in an hour. 15 minutes is a fourth of that. So that means I would take a fourth of 70 miles. Now, 70 divided by 4, if she's doing this in her head, is that something she can do probably pretty easily? No. So we're not going to use 70. She's trying to do this in your head. What is close to 70 that is also divisible by 4? 80, right? If you're doing this in your head, you're thinking, okay, let's go to 80. So we're going to think 80, and if you take a fourth of 80, how many more miles is that going to be? So we're not taking a fourth of 70 miles. What is 1/4 of 80? 20, right? So we are going, she's on the highway. She's going to go 70 miles in an hour, and plus 15 minutes is going to be about 20 more miles. So together, she is going to be going a total of 90 miles. Okay? Her car gets 30 miles on 1 gallon of gas. So if she has to go 90 miles, how many gallons of gas is she going to need? What would we need to do? Say it again.
Divide by miles per gallon.
Divide what by miles per gallon?
Miles she spends on the freeway.
Right. So that means I'm taking 90, the total number of miles, divided by how many miles does she get per gallon? 30. So how many 30s are in 90? 3. So she is going to need about 3 gallons of gas. 3 gallons of gas. Now, we had the luxury of being able to write all that down. But you have to be thinking, what are we looking for? How do I get that answer? I am not taking 70 divided by 4 in my head because I know that's not going to work out and be very easy. So you have to do a little bit of estimating. Raise it up to 80. That gives you that total of 90. Now, let's go to the second question. Assuming she makes it to that gasoline station, how much does Felicia spend per mile on the freeway? How much? What is that talking about? It's talking about money, right? So how much is she spending per mile? Per is talking about what operation? Division. Per is division. Felicia, how much did she spend per mile on the freeway? So money divided by miles. Money divided by miles. You see how I did that? How much per mile? Okay, that still doesn't give me the answer, but let's put it together. Money, what is the money? Say it again. Okay, that's one way we can do it. $3.50. What about that?
How much each gallon is?
Okay, so that's per 1 gallon. All right, what else do we know? And she can go, how many miles do you want to say? Well, we're kind of getting two things different here. So this $3.50, if we want to go with $3.50, that is for 1 gallon of gasoline. Are we going to multiply by 3? She can get, for 1 gallon of gasoline, she can go how many miles? 30. Now, there are different ways to do this, okay? This is one way. This is the beauty of mathematics, and this is the hard part about mathematics, okay? Is that there is always, usually, more than one way to do it. So, if we're looking at 1 gallon, we basically are going to take $3.50, and you would cross cancel these out. I don't know if you've done some science stuff or math stuff like this, and you are dividing that by 30. Okay? So we don't need calculators. We don't need them. So if I take $3.50, that is your dividend. That is what goes inside. You are dividing that by 30. And if you remember long division, okay, that dot goes up. How many 30s are in 35? 1. This is long division. You haven't done this for a while, I bet. And 1 times 30 is 30. Subtract, you bring down the 5, bring down the 0. How many 30s go into 50? No. How many 30s? 1. 1 times 30 is 30. Subtract, you get 20. Bring down another 0. How many 30s are in 200? Or you can say about how many 3s are in 20? 6. Let's try 6. So then you go 6 times 0 is 0. 6 times 3 is 18. And then when you subtract, you get 20 again. So you can add a 0, bring down a 0, and then you see that 6 is going to keep repeating. Now, the answer, it says, assuming she makes it, how much does Felicia spend? What is my answer going to be in terms of? It's in money, yes. So the answer is in money. Money. So it is between 11 and 12 cents per mile. Okay? Now, is that the only way to do it? No. Okay? If you understood that, great. Now, the way I'm going to show here very quickly is slightly different, but pretty much the same. It says, and I'm going to do this as like option 2. Option 2, assuming she makes it, how much does Felicia spend per mile on the freeway? So she was on the freeway for how long? How many miles? 90 miles. So she was on the freeway for 90 miles. And those 90 miles, we said she needed 3 gallons of gas, right? So if gasoline is $3.50 per 1 gallon, 3 gallons would be $3.50 times 3, which is $10.50, right? So this is just figuring it up literally from where she was on the highway. So how much does she spend per mile on the freeway? How many miles did she spend, or was she on there again? 90. So if you take this $10.50 and divide it by 90, put your decimal point up there, you are going to get the same answer. Okay? And that would be 6 repeating, so that is 11 to 12 cents. So they are both similar, it's just you were looking at this per gallon and then per that 1 gallon and the number of miles that 1 gallon takes, or for her whole time on the freeway. Okay? Any questions about that? This right here is kind of what prime math is about. Okay? You know how to multiply and divide. What you don't know all the time is when you have to do those different things, especially when you get a word problem like this, okay? You are going to have to look at it and you're going to have to break it down and say, okay, this is something I'm dividing. This is something that is getting bigger. I'm going to have to multiply. So I'm not going to give you one way to do it and say, here, take this down, model it, and regurgitate it back to me, okay? So in this class, you have got to be ready to think, you've got to be ready to process, you've got to be ready to struggle, and finally, persist. So if you are not ready to struggle or persist, this might not be the class for you, okay? I am not looking to spoon feed you how to do each of these problems, because you have done all the work that we're ever going to need for this. Yes, will I refresh things because you've forgotten? Sure. But you are going to have to think on your own. Okay? Any questions about that or what I just said? Okay. All right. What's the time? 10 after, and it's like 06. Okay. Here's what I want you to do. Turn to page 7. And I want you, on page 7, just to write down in this upper left-hand corner, what does that say? Original number. Any positive number, and write it at the top of that page, in that first column, first row. Any positive number. Write it at the top of that page. Do not show your neighbor. Do not let them see it. Okay? And then tomorrow, you are going to meet the great Fedini. Okay? The great Fedini. So after you have your positive number written in that top blank, we are done for the day. Nope. Nope, not yet. We'll do that tomorrow. All right, so remember, you still have that first homework. What makes you happy? Make sure that you upload a picture and talk to me about it. I think it says a minimum of 3 or 4 sentences. Please make sure they are complete sentences. Okay? And that's all we're talking about so far. All right? Any questions? Yes? Yes. It's the end of 10 minutes. It's going to be the beginning. Can you wait 10 minutes after the bell rings, or that'd be like 17 minutes? No? Okay. Now you only get 4 for the semester. Okay. All right. I still do not have Uno cards. I should be able to get some tonight. Okay? Because I had chorus last night, an hour there, 2 hours there to stay there, and then an hour back. All right.